equivalent point, the more advanced level. On the first picture, I have a strong acid neutralizing a strong base. When you put strong acid in, once you put the full bottle of strong acid in, what will be the VAS be? It will be high concentration of H plus ion, so the pH will quickly go to 1 or lower. Once they fully neutralize, as NaOH, it can go up to 14. So the middle line, pH 7, that is the equivalent point. Look on to the next picture. This time, I'm using a strong acid with a weak base. Weak base, for example, ammonia. Weak base. Strong acid. Once I put the pipette in, the VAS will go to 1, pH 1, high concentration of H plus ion. Weak base. Weak base will never reach to 14. It will only reach to about 10. So, don't expect the equivalent point will be at the 7. The equivalent point will be around pH 4. If you have a weak acid and a strong base, weak acid, once you put that in, they will not reach to pH 1 because they partially ionize. Strong base can go to 14. So, to calculate equivalent point will about pH 9. Understand this relationship. Now, we're going to assess this equivalent point by different indicator. Methyl orange is very good to measuring change of weak acid between 3 to 4. B blue is very good to measuring change in pH 7. Phenolphthalein, very good to measure change between neutral to become slight base. Now we apply it onto our experiment. Strong acid, strong base, equivalent point at pH 7. Which indicator will suit the best so you will test this change? B blue, because they change at 7. The middle one, HCl and NH3, strong acid, weak base. Equivalent point will be changing at pH 4. So what will be the best indicator to use to measuring the change? Methyl orange. They will give the best indication. Weak acid and strong base, they changing at pH 9. What will be the best indicator to use to measure this change? Phenolphthalein. So student, please understand the molecule action and the graph relationship. This graph is the actioning of this titration. this is an example. Students always thought pipette is to hold acid. Is that the case? No. You can use it to hold acid. You can use it to hold base. As same as apply to burette. So there's no fixed rule. Okay, if I use strong acid and strong base, here I'm using the NaOH for pipette. What should the graph be showing? Would it be different? Guess. In the beginning, once you put it in, it will quickly hit to pH 14. The vase will show pH 14 full with base. And then you neutralize with acid until they reach to pH 1 HCl. So you can see this graph become upside down now. So titration don't always fix mine in say one side must be acid as pipette must be acid, burette must be base. I never say such rule. And what is the rule behind of titration? One simple rule. Acid and base, when they fully neutralize, the mole should equal to mole. If diprotic, 1 should equal to 2 mole. And then we're using this mole relationship to find the unknown sample concentration. That is titration calculation. We do another one. What happened here? Pipette are holding diprotic strong acid. And then I neutralize with a base. What the graph should look. Think. On a monoprotic, if I use 25 ml to reach fully neutralize of base. If diprotic, I need to use double. I need to use double. Here I use 20 ml. Here I need to use 40 ml. I will use more volume. Why? Because one acid I require 2 base to neutralize. So after studying this few examples, I hope students understand titration and the equivalent point graph and the relationship.